Bismillahirrahmanirrahim. Welcome everyone to the course of Finite Element Analysis of Structural Systems for the spring 2020 semester. In today's lecture, we will discuss or we will go through the overview of the course. We'll see the general guidelines of the course, and we'll also try to review some of the mathematics that we'll be frequently be using in this lecture or in the coming lectures. So let's start with the objectives of the course. That what are the key objectives that I've set for this course? The course is a beginner's level course, and this course will provide you an introduction to the finite element method for the analysis of solids and structures. So we are specifically will be dealing with the finite element analysis for solids and structure, and not for the fluids. The course is designed to help students and engineers to understand the theoretical basics and practical applications of the finite element method. What you will learn after taking this course. So upon successful completion of the course, you will be able to solve continuous system mathematical models using approximate solution methods. You will be able to understand basic principles and concepts of the finite element method, and you will be able to formulate basic mathematics of finite element for simple problems as well. You will also be able to formulate finite element matrices of some very basic types of finite elements, like the 1D truss element, the Euler-Bernoulli's beam element, the plane stress and plane strain 2D elements, and 3D solid finite elements. So we will try to cover up some key elements that you might be using in your analysis in the future. So how can you construct the element matrices, and what are the characteristics of element matrices? So of course you will be able to formulate those matrices as well. And the fourth outcome will be that you will at least understand the basic structure of the simple finite element computer program. Of course, this objective will not be judged or assessed, but this will be for sure an outcome, and we will go through several numerical and practical examples in which we will try to code the finite element method as well. So you will also learn the basic structure of the simple finite element computer program in this course. So these are the 3 or 4 things that you will have at the end of the course. Course outline, you might have seen a very detailed course outline and its weekly distribution in the basic course info folder or the file that I have uploaded in the Google Classroom, but just go through it very shortly. So we will try to introduce what is finite element method in the early lectures, and we will try to review some of the continuum mechanics, some vector and tensor algebra that we will be frequently be using in the coming lectures. So I'll just simply revise them. You may use some other textbooks or some other class notes for other courses like calculus or algebra or structure analysis class notes. You can look into those class notes for review. We will also learn introduction to solution methods, I would say approximate solution methods for structural mechanics problems. Then we will formulate finite element for the simple truss and beam elements. We'll try to formulate finite element for the 2D plane and 3D continuum. We'll also see what is isoperimetric elements, how the element matrices for such type of elements can be formulated. And then once we have the equilibrium equations, so how can we solve those equilibrium equations? Primarily, we will look into the cases of static case, not the dynamic case. And we'll also look into that how we can apply the constraints, the boundary conditions to those equations. And of course, we want that our analysis should be error-free, or at least it must have smaller errors. But for that, we must know the magnitude of the error. So we'll also see that what are the different methods that are different criteria, how can you calculate the errors, and what is convergence in finite element method. So this is the brief outline of the course. So hopefully we will try to cover up some basic of the finite element method in this course. References, of course, you can use any reference, all the references, books or material available are good. I'll not say that they are bad. I have mentioned some of the very key references that I personally used it. I made these class notes or these lecture from the first three books. The book by the K.J. Bathe, Finite Element Procedures, the book by Fish and Belichko, A First Course in Finite Elements, and third is also a very good book by R.D. Cook, Concept and Applications of the Finite Element Analysis. So my first half of the course, that is up to the midterm, will be primarily from the Bathe's book, Finite Element Procedures, and R.D. Cook book, Concept and Applications of Finite Element Analysis. Whereas the later part, after the midterm, the course I have made it from the book of Belichko, A First Course in Finite Elements. But you can also, for references and for detailed study, you can also look into other books by Belichko, Hughes, and Sinkwich. So these are all very nice books. Now, you may find it on the internet as well. Yeah. Okay, how you will be assessed during the course. So you will have the final term exam that will carry 30% of the total marks. That will be a written exam at the end of the semester. You will have a midterm exam of 10% marks. Then we will have oral presentation that will be held at the end of the semester. I will give you a research article. You have to read it, you have to understand it, you may discuss it with your peers, and then you have to make a small presentation, 15 minutes maximum, and present it in front of the class, and we will have some chit chat and viva voce examination on that, just to see your understanding about the course and how you understood the paper. So that will carry 20% of the marks. Home assignments are very important in this course. I will frequently be giving you many home assignments throughout the semester. You have to solve it, carefully solve it, and solve it yourself. You may discuss it with your peers, with your friends. You may look into some reference books as well, but try to solve it by yourself. I should not be seeing any copied home assignments at the end of the day. And you should, if there is a deadline for the assignment, so try to stick with the deadline and try to submit the assignments on their deadlines. So this is the grading criteria. Contact details, I have already shared with you the Google Classroom for this. You have already enrolled. If you have any other queries, you may always contact me through my email ID. And I have also uploaded the lecture notes and other relevant material. I will keep uploading on the Google Doc folder. The link is also mentioned in the online Google Classroom. So now if you have any questions, so you may ask. If not, then I will ask you, why FEM? Why are you sitting in this class? Why you want to learn the finite element method? What's the reason? Yes, please answer. Any comments? Yeah, one of the reasons that why you are learning this course is it's a widely used method to predict the response of the structure. Of course, whenever we want to find out whether the structure will fail under certain type of loading or not, or how the structure will behave, what will be the deformations in the structure, or if a structure is subjected to some temperature load, so what would be the heat flux in it, or if a structure is subjected to some chemical load, so what will be the damage or other effects in the material. So whenever we would like to look into the response of the structure, definitely we will be using finite element method, and it's being used both in industry and in research field. Yeah, of course. Another reason could be to study finite element because we want to be a good finite element user. We don't want to we want to avoid worthless results. Finite elements will give you some results at the end of the analysis, but it's your responsibility to judge whether those results are correct or real representative of the structured behavior or not, because once you understand how the displacements are computed, how the stresses and strains are computed, once you know the basic ingredient, how these different quantities are calculated, so then you can tell whether the results are good or not. Maybe you get some results which are very bad, but that may be because of the fact that you haven't calculated the stresses correctly, right? For example, you might calculate the flexure stresses using the simple Ehlers-Bernoulli beam theory, but the beam might be showing large shear deformations. So it means that you haven't calculated, or you are not using the correct stress equation to take into account that shear deformations. So once you know the basic ingredients of the finite element, then you will be able to understand the results. So one of the reason of studying this course will be to understand the basics of the finite element method, so that you can become a good finite element user, not just punching some keys on the keyboard. And of course, another reason could be to get some extra skill. Of course, it will add an extra skill in your skill set. So that could be a reason, and also to get a degree and get some credits. Now, finite element in engineering was initially developed on a physical basis for the analysis of problems in structural analysis, but very soon it was recognized that the technique could be equally applied to the solution of other classes of problems as well. And nowadays, it's an important and frequently indispensable part of engineering analysis and design. So now it's a very important part of computer-aided design, because now we have realized that the basic principles of the finite element are not only valid for the structural mechanics problem, but you can also apply it into myriad fields of engineering. You can also apply it for solid structures, for fluids, for heat transfer problems, for aerospace engineering, for biomechanics. So it's a very versatile method that can be applied to myriad of fields of engineering. For example, you can also analyze multiphysics problems. For example, a mechanical engineer who wants to see the response of a particular machine under different loading conditions. So he may look into the response of the machine under static load, under dynamic load, under mechanical load, or he may also study the effect of bodies under temperature load as well, or a combination of mechanical and temperature load. And and these temperature loads may be some externally applied, or may be generated due to some damage growth as well, or due to friction within the different parts of the body. So mechanical as well as thermal load both are acting in the body. So it's a multiphysics problem. Similarly, if a damage occurs in the body, so there may be friction between the crack faces or the voids that may also generate or dissipate energy due to that friction as well, due to the friction between the contact surfaces of the cracks. So again, you have applied only a mechanical load on the body, but due to the damage growth, some heat has also generated. So it's a multiphysics problem. So you may use finite element method for analysis of multiphysics problems as well. Similarly, you can also perform multi-scale analysis. There might be many instances where you might be interested to find out the true response of the structure. You know that in reality, no structure or no material is pure homogeneous, right? So there are always some inhomogeneities present in the body. For example, if you take the example of concrete, so when we analyze it, you can analyze it by assuming it a homogeneous material. But in reality, it's not a homogeneous material. And in order to see the effects of the fine aggregate, the coarse aggregate, the cement particles, and the transition zone between the cement particles and the aggregates, and you want to see the effect of all these ingredients on the mechanical behavior of the concrete, so you may go for the multi-scale analysis, where you may perform analysis on the lower scale to take into account the effect of all the ingredients and then project that behavior onto the global scale. Similarly, if you would like to analyze aeroplane structures, so again you may use multi-scale analysis as well for that. As you know that most of the aircrafts were made from fiber reinforced composites. So you would like to, in order to calculate the true response of the aircraft under the influence of mechanical forces as well as wind forces, other machine dynamics, you might be interested to see how damage growth between the fiber and the matrix material. So you may start your analysis at the very basic level, how the damage will grow between the matrix and the fiber, and then you know that a lamina is composed of many fibers embedded in some matrix material, and then when you combine different laminas together you get a laminate, and then these laminates are then used to make different parts of the aircraft or the fuselage. So you may perform analysis at different levels, at the micro level, at the meso level, or at the macro level, just to see the response of the structure. And as you go more deep into the problem, like if you analyze the problem at the mesoscale level or at the microscale level, you will get the true response or the true stress strain behavior of the materials. For example, if you are analyzing the structure of an aeroplane at the macro scale level, so you will always assume that the material is homogeneous, and you will use a very simple relationship between the stresses and the strain, or you might use a linear relationship or a bilinear relationship between the stresses and the strains. But if you go quite deep, if you perform a micro scale analysis, so then in that case you might be taking into account the true relationship between the stresses and the strain at the global scale. Similarly, it has wide application in the field of biomechanics, where you might want to either automate the operations. For example, people are using this kind of finite element technology to automate this stent injection in human arteries. Similarly, you can also analyze different body parts of the human being, or you can look into the growth of the cancerous cells in human bodies using the finite element method. Similarly, if you look into the civil engineering problems, you may also analyze the damage growth or the crack growth problems in civil engineering as well. Or there are also in the pipe industry different pipings are made from the laminated cylinders where the fluid is under great pressure. So these are pressurized cylinders which have to sustain large pressures, so they may be made up of laminated material. So of course you can again use the finite element methodology to basically look into the behavior of these cylinders under different kind of forces, under mechanical loads as well as under pressure loads or thermal loads as well. Thank you so much.